right now I'm super excited to go in and see what this infrastructure looks like, what this data center looks like with the kind of investment that you put in. And I'm hoping that for our audience, we'll be able to give them a taste of why they need to look at IXAfrica as one of the places that they can host their solutions.
Thank you, Moses, and
Asante
we welcome
sana.
you to walk into the future with IXAfrica.
Thank you so much.
Thank you.
So in this facility, we have 4 diverse fiber entry points, 2 on this level. It's called west side. One is coming through the main gate. Another one is coming through the rear gate. We have other 2 diverse points at the rear side of this facility. That's just to ensure the redundancy and diversity of the cables, the fiber cables coming in. So when the cables, that's the fiber cables from the operators land in the facility, they're joined through a riser. A riser is here inside this building. So when the cables enter the riser, they're routed to the MMR. MMR is the Meet Me Room. The Meet Me Room is where the customers and our clients meet now, diverse and several fiber operators and carriers to do the interconnections and peering. So maybe you can just enter the building and proceed with the tour.
All right. Thank you.
In terms of the secure access measures that were put in place, once a customer comes in, you've sent your details to our security department. They have logged you in. Then once we read the reception here, you are signed in, you're logged in, using your details on the tablet here.
So what you're saying, in a good data center, there's no way you just walk in.
No.
It's super secure. And even I noticed that when we drove in earlier, there was no signage outside. So unless you know where you're going, you can't just come here, right? That's deliberate, right? Yeah. Thank you. All right, let's continue.
Thank you, sir. Okay, let's proceed. So in terms of physical security, this is a man trap. It's able to trap a human being. This actually, basically, literally is a man trap. It traps you in. So you are not able to leave this enclosure inside here when one door is open. You need to close all the doors first before another door opens. Maybe I can just demonstrate to you how it's working.
The man trap. We're going into the man trap.
Yeah, we're entering the man trap. So just hold the door. Just hold it open. Let me try and open this. You see, it's not opening. It's trapping you inside.
So once you shut it?
Yes. Yeah, once you shut it, then it will be able to open.
Okay, let's see how this works. Let's shut, Excellent. So now we're on,
Those are some of the physical security measures that we put in place.
And
this is our network operating center. This is where all the monitoring of the data center, physical security, monitoring of our systems, control of everything within data center is done. Maybe you can just go inside and just have...
this is the nerve center, huh?
Yes, this is the nerve.
Wow.
So this is where our engineers sit. As you can see, some of them are here. We are monitoring every part, every section of this facility using the CCTV cameras. We have over 120 CCTVs inside this facility. At the same time, we are monitoring the access in the facility. This is the access control screen. This is the screen for the CCTV, and this is the screen for the BMS. BMS, the building management system, which we are using to monitor the power board, how much energy we are consuming for our customers, monitoring the temperatures for the data hall. As you all know, our data center has IT equipment, IT networking equipment. So, and all these equipment needs to work under a certain temperature, an optimum temperature of up to a maximum of 27 degrees Celsius based on the ASHRAE standard. So we have installed sensors in the data hall and in the boards to monitor all that, and we can be able to monitor all these systems on the centralized screen. So these are just the desks for the engineers who are working on this. So in terms of fire, we have installed fire alarm systems just to monitor any outbreak of fire so that we are actually alerted through the detectors.
Fantastic. I love the way everything looks so structured. You know, the cabling, the metal, everything is just very perfectly done.
It's perfectly done and neat. Yeah, we had the best contractors to do the work. Okay, so once you enter the data center, I just explained to you about the fiber cables coming in. Once the fiber cables come in, they go into a room called a meet-me room. So this is, on this floor we have two meet-me rooms. This is the first meet-me room, we call it meet-me room B. Maybe you can just enter the room and I'll be able to explain what a meet-me room is. A meet-me room is a secure space or a secure room inside a data center where multiple customers, multiple clients interconnect with numerous multiple operators or internet exchange providers or ISPs or just normal internet exchange providers. So everyone comes in through this MMR. This is where the fiber operators come in through the MMR. So we assign some racks. These are the racks for the fiber operators.
Okay.
When they are here, we can do now our interconnection. It's called cross connection to now the customers who are situated in the data hall. So if you want to connect to any internet provider, Safaricom is coming in, let's say for an example, and you as a client or a customer, you're located in the data center.
Yes.
So you will pull a cable all the way to this room where you now do a physical connection between your ISP. That's it. In terms of cooling, although the equipment here, some of them are active equipment and passive equipment. Active equipment require cooling because they consume power, and we have cooling equipment here. They are called CRA units, computer room air handlers. They have two modes.
Okay.
One of the modes is a free cooling mode, which uses water, just general water.
Okay.
You pour inside the line, and the other line is a DX system, a direct expansion system, which uses refrigeration and compressors. So in this particular room, the temperature is set at 24 degrees Celsius. That's the optimum temperature for cooling inside this room. So when you want to cool this room using water, because we have two modes of cooling for these coolers. If you want to use water, it means you are using free cooling, not DX. I'm now talking in terms of efficiency, because if you're not running compressors to drive the refrigerant along the circuit, it means you're very efficient, because it's only compressors that consume substantial amount of energy in cooling units. So when you're running on free mode, it means you're running using water alone, just running through a pump.
With no refrigeration?
No refrigeration, no compressors are off. And we can only use this mode of cooling if the ambient temperature is low enough to provide the cooling that we require.
So the cooler days, yeah?
Yeah. So in colder days, maybe when the temperature is around 19, because if we have a temperature difference of 5 degrees Celsius between the required temperature in this room and the ambient temperature, which is outside, a difference of 5 degrees Celsius, then the free cooling will kick in. It will now start cooling this particular room.
And this is automatic?
It's automatic.
No one has to go in and actually
No one has to go in, yes.
Wow.
When the ambient temperature rises, then the DX system will kick in. So that means it's very efficient in terms of cooling. We're able to save power consumed in terms of cooling this facility.
Fantastic.
Yeah.
Thank you.
From this room is where we now interconnect our customers. This is where we pull the fiber cables to the data hall.
Okay.
Yeah, for the exchange. So we have some contractors who are still working here. They're just doing final touches on the next phase. Currently, we have already finished phase 1.
Okay.
And we have some of our clients who are already here. Customers have already been set up. They're now live. So this is just a second phase that we are finalizing on. So this is the second MMR. As I told you, we had 2 MMRs. This is the second MMR, the same setup as the other MMR. Yeah, so maybe you can just proceed and go to the data hall.
Okay. The data hall is where?
The data hall is where now we set up our customers.
Okay.
If you are an enterprise, you are a bank, you need to migrate your IT equipment, your telecommunication room. You don't want to house it anymore at your facility. Now you need to house it here. It's called collocation. You need to collocate here. Then this is where you bring your equipment.
Oh, okay.
Yes.
So
this is the data hall. We already have some customers who are live and set up right now. Could you hear the noise? Yes.
All the equipment.
And all the equipment, yes. These are our racks. This is where the customer equipments are housed. If you have things like servers, switches, routers, this is where you come and place and install your equipment for the connectivity purposes. You can see in terms of power arrangement, we are using bus systems. We are using, everything is overhead. Yes, yeah. Most of the data centers, maybe the one you visited, they are doing a raised floor. Yeah, you can see tiles on the floor.
Yeah,
so everything is running underneath. But ours here, everything is running overhead. That means we can have high density racks. We can be able to place heavy racks in terms of equipment that are able to be housed in those racks. Also, we are able to install big racks that are able to have high density power. Like you can see this rack here, it's a 47U rack. It's not a normal 42U.
It goes all the way up, huh?
Yes, it's a 47U rack, and we are able to scale up to 52U for this particular data hall. For this room, the reserved power for this room is 1.5 megawatts. Yeah, it's able to house IT power of up to 1.5 megawatts. So it's actually scalable. As you can see, we have only installed some few racks, but we have enough space for all those enterprises who want to maybe collocate and bring in or look for a larger space. Yeah. So for a data hall, in terms of cooling, it's very important. These are the key elements that you need to consider when you're setting up the data hall. In terms, it's cooling and power. First is cooling. So as you can see, we are cooling the entire space. The entire outer space is being cooled. But now, in order to avoid mixing the hot air and the cold air, we need to do something called containment.
Okay.
Yeah, here we have done a hot aisle containment. That means we have enclosed where the hot air comes in. So you can see this containment here is for the hot air. So we are enclosing the hot air. It's not able to come outside and mix with the cold air.
Okay.
So that means we are very efficient and in terms of cooling.
Then it channels up there.
Yeah, the channels up there. We have a cooling equipment. It's somewhere up there. I'm going to show you. That's able to suck in the hot air that's being released by the equipment, and the cycle continues.
Okay.
Yes. So in terms of physical security, we have CCTV that's installed, and the data hall, every point of this data hall is being monitored 24/7 and recorded. Yeah, so if anything happens here, you can be able to retrieve your footage and it's stored up to 90 days, 3 months. In terms of fire suppressions, because we need to ensure we are suppressing fire. In case fire, there's an outbreak of fire in this room, we need to ensure we are quenching the fire. And you need to come up with mechanisms of ensuring the fire is quenched. So one of the mechanisms we've ensured, and it's actually a new technology right now in the data center, it is a water mist.
Water mist.
Water, yeah. We are
That's
cooling.
water.
Yeah, we are cooling this data hall using water. It's water mist, very small droplets of water, up to 10 microns. So you can see those nozzles. Those are the sprinkler nozzles for the water mist. If there is a fire outbreak here, we have a pump station. Our central pump station is located somewhere in the facility that's able to pump water, and it sprays everywhere. Just a mist, not just actually droplets of water, just a mist up to very small droplets of water.
It's like the latest technology.
It's a technology that it's been there, but in terms of cooling data centers, it's a new one in East Africa, if I may say so. So you can see we have detectors also to sense the fire. Once they sense the outbreak of fire here, they send a signal now to the pump stations to be able now to release the water.
Is this the water cooling?
This is another system of cooling that's different than the one I just explained.
Yeah.
This is a different cooling system. It's called ISE, indirect adiabatic coolers. They have 3 modes of cooling also. It has free cooling. It has wet cooling, and it has a DX cooling. Free cooling, it's where we cool this data hall using the ambient temperature.
Okay.
I mean the ambient air temperature, ambient air. Just air alone. We just get the outside air and use it to cool the air inside the data hall. And it's an air-to-air technology.
Okay.
Yeah. It doesn't mean that we are getting the air outside and getting it into the data hall, because it has impurities and we cannot afford to bring it into the data hall.
So you sanitize it.
So, no, we don't. Of course, there are filters, but they meet through an air exchanger. Yeah, there is a heat exchanger inside this cooler, where now the the two, the air coming in from the data hall and the air coming in from outside meet and exchange the heat. So that's why we call it air-to-air technology. So that's the first mode of cooling, and you can only use this mode of cooling if the ambient temperature is also low enough to cool to cool the data hall to full capacity. If you are not able to do that, to cool this data hall using water, using free air, then we do wet cooling.
Okay.
Wet cooling is where we use evaporative cooling. In fact, evaporative cooling it has been there since memorial. Even during early days, even people used to cool houses using this technology, because some people used to put some damps, some clothes inside water, and you hang on your windows, so that the air that's coming in, it goes through the damp cloth.
Yeah.
So coming outside, it comes as cool air. It's the same technology that we're using here.
Okay.
The air is sprayed. There's water sprays. The water is sprayed at the incoming chamber of this
it lowers the
cooler.
temperature.
Yeah. So when the air comes in, the sprays of water are able to lower that temperature because before it goes to cool the data center.
Okay.
The last one is now the DX cooling, the normal DX cooling, which includes the refrigeration system.
Yeah. Okay.
Yes.
Awesome. Nice.
So as you can see, we have enough space right now for all the enterprises, all the hyperscalers, bespoke data center, bespoke space. Yeah.
All this,
Yeah. So anyone who wants to get a very huge space to, set up their racks, 100 racks, 50 racks, the space is there for them.
Excellent.
Yes. So this particular room is able to house up to 250 racks of minimum rack density, power density of 6 kilowatts. Yes.
That's a lot.
Yeah, it is. It is. And
Wow.
it's actually scalable.
Keep growing.
Yes.
Wow. Does that bring us to the end of the tour?
Not yet. This is just the connectivity part. This
Okay.
is just we still need
More
to
to
go
go.
to the we still need to go to the power rooms.
Okay.
Yes.
Okay, where the power comes from, huh? Okay,
Yeah, where the
okay.
power comes from. Yes. So this is where we're now getting our power distribution. In this room, we have two diverse lines coming from KPLC, two diverse lines, just for redundancy for the power. So we have 11 kV lines coming in, two lines.
Okay.
Yes, and we are in the process, actually, we've just started construction of our 66 kV GIS substation. It's a gas insulated substation.
Okay.
It's also a new technology in terms of substations. Yeah, so when the power comes in from KPLC, it's distributed, two lines, they're distributed into 4 streams.
Okay.
So the 4 streams is stream A, B, up to D.
Okay.
So for this corridor, we have stream A and B.
Okay.
So once we get in the 11 kV, it's stepped down using the transformers to 415 kilovolts in these rooms. So it's a live room, maybe let's just peep in through here.
Okay, okay.
Yes. Yeah, so our 11 kV, which is medium voltage, it's being stepped down to low voltage in this room. We have a transformer that is stepping down the voltage to 415 volts. So from here, we evacuate the power using the bus systems. You can see.
Yes.
We are not using cables. We are using bus to evacuate the power to the low voltage rooms.
Wow.
Yeah.
Okay. You know, I'm now looking at this and wondering if somebody's an IT manager or a CIO, how can you possibly do this in-house? You can't, can you?
You can. It's always through experience. You can always learn to do that. We have a low voltage room. These are the low voltage rooms.
Yes.
And, they have the low voltage distribution boards and the UPS.
Okay.
So the UPS needs to use our power backup device in case we lose power. In case we have a power blackout from KPLC, we need to have a UPS to sustain our IT equipment. And it's sized for a minimum of 9.5 seconds to sustain our load for 9.5 seconds before the generator kicks in. Because we have the generator, Once you have a power blackout, you know, generator, we need to give it generator some time to synchronize
To build
and do
up.
other things to build up voltage
Okay.
before it supplies power to our equipment.
Okay.
So within that lapse, UPS comes in. It's able to sustain the loads for that few seconds before the generator now comes in.
Okay.
Yeah. So we are using lithium-ion batteries. It's all a good technology in terms of storage.
That's like the EVs, huh?
Yes, EVs, like your phones, they use these lithium batteries. So even in terms of space, lithium batteries take very little space. As you can see, this is able to support 1 megawatt of power. And you see the space itself. If it was a flooded batteries system, then you could be seeing a lot of racks here full of batteries.
It's high capacity, huh?
Yeah, it's actually takes very little space, and its discharge and recharge cycles are more as compared to the other, as compared to the flooded batteries.
So this also has like fast charging in its own way.
Yes, yes.
Okay.
Yeah.
Wow.
Yeah,
And
so-
this is doing the whole setup as it is right now.
Yeah, right now it's working. This is stream A. It's able to support stream A load. We have stream B, stream C, and stream D.
Wow.
So this is just one of them. Okay, so as I've told you, all these are streams. We're just
Okay.
it's just mirrored. Yeah.
Okay.
Just mirrored.
Redundancy,
So,
huh?
yeah, so this is the low voltage room. Once now we step down our voltage to 415, then it comes to this room. This is where we do now our distribution. And this is where our UPS is placed. We have our UPS system is here. This is our UPS. We have a board. When power comes in through this is the power evacuated from the TX. The TX is the transformer
Yes.
to the input board of the UPS. Then from here it's taken to the UPS, it's conditioned, then up to the output board. So this is where we're now distributing our power to our critical loads.
Okay.
Yeah, like servers in the NOC, like our office computers, we supply them from this board. But anything else like equipment that, the cooling equipment, you're supplying them from the raw power, which is from the input board. Still we need to cool our equipment, we need to cool our power boards because they are working.
Okay.
We need to cool our UPSs, it's working. And we have the same setup for the cooling systems.
Both the refrigeration and the water.
Both refrigeration and water. You can see this is the water line. This is the water line. It has a condenser on the roof.
Okay.
Where it's condenses the heat exchanger. It's on the roof. Yeah.
So it comes out,
Yeah,
cools it, and comes
it's
back
just a
again.
cycle. It comes out, it's cooled up there, then it comes back when it's cold. It releases its coldness here, then it goes back as hot water or warm water. The cycle continues.
Okay.
Yeah.
Again, I love the cabling and
Yeah, the setup. You can see
Yeah.
even we've used different colors of cable ladders just for identification and troubleshooting.
Okay, so you
Yes.
know what is where.
Yeah, what is where and what is going where.
Excellent.
Yes. Actually, in this data center, this is the first data center we are doing. We have two data halls. One is 1.5 megawatt, the one you just saw, this one. And on the top floor, we have another one, which is 3 megawatts. So the total IT power for this data center is 4.5 megawatts. Yeah, and there are plans to do further more scalability in terms of more data centers in future.
Is that one of the highest in the country?
Yes, it is.
Okay.
It is the biggest.
Wow.
in the
Oh, it is the
country.
biggest?
It's the biggest. Yes.
Not one of.
It's the biggest. Yes.
Okay.
Yeah.
Excellent.
Okay.
Great.
So you can see the arrangement of our baskets, how neat it is, and how colorful and conspicuous
Beautiful,
it is.
huh?
Yes.
Very engineered.
It is. It is.
Yeah.
It's well designed and well executed.
So the amount of time it takes to do this took what, years, months?
This is years. We started construction in the year
February 2021.
2021. So it took
2021.
at least 2 years to do.
At least 2 years. Yes.
2.5 years. Huh?
2.5. almost
From
3
ground
years.
up?
From ground up. Yes.
Okay.
Yeah.
And it started operating in October.
Yes.
so it's
October.
brand
Yeah.
new.
Right now we are live.
Okay.
Yeah.
Wow, that was awesome. I think what we're seeing here is something that every IT manager, every CIO, every CEO needs to see, because I think when they see what this is it becomes very clear in people's minds that this is
Yeah.
what it takes
Exactly.
to bring your solutions to a data center that can actually allow you to operate at the best level as a business.
Exactly. We have SLAs that ensures we have an uptime of 99.982.
Yeah.
That is to ensure that we are providing optimal cooling for your equipment, for our clients' equipment, for the enterprise equipment, for whoever decides to come and collocate in our facility. We have redundant power systems. Everything is redundant. Cooling system is redundant. Our cooling systems are of a top-notch, high-level technology. You've just seen, they have explained to you how they are working. Most of the cooling systems are using direct refrigerant, which is very, very power-hungry because of the compressors. But here we are able to balance and switch between free cooling and the refrigeration cooling, and that's conserving power and improving the efficiency.
And being good to the environment.
Yes, and good to the environment, of course.
Yeah.
Yes, yeah.
Yeah. Wow. So thank you so much,
Okay.
I guess, and I really appreciate it.
Thank you.
Unless there's anything else, we really appreciate the tour. And I'm hoping that our viewers and our audience are going to really now understand what it takes to build a world-class data center in Kenya.
Thank you for coming.
Yes,
Thank you, and for the viewers, any prospective customer, if you have IT equipment, IT room, telecommunication room that you are not able to manage well in terms of provision of power, in terms of cooling, we welcome you to IXAfrica to collocate with us. It's a top of, how do I put it, a state-of-the-art facility that we are able to offer our top-notch services to you. You are welcome to IXAfrica Data Center. Thank you.
Great. Thank you. So everyone, thanks for joining us today for this podcast and also this tour of the IXAfrica Data Center. This is a state-of-the-art $50 million data center launched here in Nairobi in October of 2023. It's amazing technology, it's an amazing facility, it is able to be environmentally friendly through the features they've put in, but most importantly for those who are running technology solutions within their organizations and also international providers, we do have right here in Kenya a world-class facility that you can use to run all your applications and cloud systems in the cloud. Thank you very much for joining us today. Once again, it's me, Moses Kimibaro, on the Pure Digital Passion Podcast. We'll catch you in the next one.